Okay, so this is going to be our review for Unit 2A. Yes, we really kind of are at the end of this unit. So we're just going to go ahead and jump right in. Reminder, make sure that you are not watching this video until you have attempted this study guide at least once. So as a reminder, this is calculator active. You're allowed to use your notes and resources on the study guide, just not on the test tomorrow. Which of these represents a function? Remember, a function is just something that satisfies the vertical line rule, meaning I can draw a vertical line anywhere on this graph and it is not going to cross the line twice. This crosses twice here and here, so it doesn't work. For this one, it doesn't work there, so I try another spot. For these two, this is the only one that I can draw a vertical line wherever I want, and it is not going to cross more than once. It almost does here in the middle, but not quite. So the answer to the first one would have been the third option. For number 2, which statement describes the definition of a function? So if you checked your notes, the definition of a function is something along the lines of that for every input there is one output, meaning the x value only ever has one possible y value, and that would be a. There is exactly one output for every input. For number 3, which of these tables does not represent a function? So remember, a function is just something that the x value did not repeat. So 2, 3, 4, that works. 4, 6, 7, that works. 2, 4, and 4. That did not work. The x value repeated, so it's not good. For number 4, which of these represents a non-linear equation? So if you recall our notes for linear versus non-linear, a linear equation cannot have a variable in the denominator. A linear equation cannot have absolute value or the little square or the square root, and it cannot be something like blanking on it. Whatever it would be, it's not going to work if there is an exponent, and that's what this one is. Technically, looking it over, I think our notes say it can't be x equals something, which means that one isn't going to work. So I'll redo number 4 by the time you guys get to it. This won't be an answer choice. For number 5, the values in this table are from the graph of a function. Which function would match these coordinates? So for this one, we did an activity briefly like this, where we had these tables and an equation followed by a graph. This was one of our worksheets last week. So all we have to do is see which of these is going to work. Somehow, a 2 became a 1, so we'll just plug it in for each of these. I'm just going to go 2 and 1, because those are small, positive, easy numbers to work with. So if I replace this x with a 2, I have 3 times 2, which is 6, minus 5, and that equals 1, so it works here. For this one, if I replace the x with a 2, I'll have 2 squared, so 2 times 2 is 4. 4 minus 15, that's definitely not 1, so this one did not work. For this one, again, replace the x with a 2. 4 times 2 gives me 8. 8 minus 3 gives me 5, so that one did not work. And this one, you can already kind of tell, again, is not going to work. This one would be 2 squared, which is 2 times 2, then minus 7, which would give me negative 3. So the only one that actually worked is this first one. All right, and that's going to be the tip of working with these type of problems, is always go for the easiest pair of numbers to work with. There's no need to beat yourself up trying to deal with a negative 2 and negative 11 when a positive 2 and positive 1 can do the same thing. For number 6, this table shows the relationship between x and y values, and it's asking which equation or which function matches the given values. Same as the problem before, we're just trying to see which one of these equations works. So I'm going to just pick the smallest one, 6 and 22. So if I replace my x value with a 6, this should equal 22. 6 plus 16, that does equal 22. I replace this one with a 6. I've got 6 times 3, which is 18, plus 4. That's also 22. So far, those two both work. For this one, replace the x with a 6. 4 times 6 is 24 minus 2. That also works. And then this one, 5 times 6, I get the feeling this one's going to work too. That gives me 30 minus 8, and that's also going to be 22. So we know that all of them would work for this first function. So I'm going to skip to 8 and 30 then, since it seems like this problem is trying to throw us off. So this time, if I replace it with an 8, we should get 30 for one of them. So let's go ahead and cross these out and replace them with 8, replacing with an 8 in parentheses where possible. So 8 plus 16, no, that is not 30. That's 24. 3 times 8 plus 4, well, 3 times 8 is 24, plus 4 is only 28, so that did not work. 4 times 8 minus 2, well, 4 times 8 is going to be, that's going to be 32, minus 2 does give me 30, so that works. And this one, 5 times 8 is 40, 40 minus 8, that's going to give me 32. So there we go. Looking at this part right here, we were able to figure out it had to be the third option. So that's what we get for this third option. For number 7, we have 4 different tables, and it's asking which table represents a function. Remember, a function is just something that the x value is not repeating. So -3, 0, 2, and 5. I don't see anything repeating, so 1 is a function. -4, -4, x is repeating, table 2 is not a function. Table 3, -7, -2, 0, and 6, nothing repeated, so table 3 is a function. For table 4, -4, -1, 3, and 9, none of those repeated, so table 4 is a function. So everything except table 2 is a function. So that's tables 1, 3, and 4. For number 8, once again, it's asking which of these is a function. So we're just looking at the x value, or the first coordinate, and seeing if they repeat. So -10, -5, 7, and 9. Well, none of those repeated, so that must be our function. And you can see the second one would not be a function because the 8's repeat, -8's repeat. Same problem with option B or option C. And the same problem happens in our last option. So for number 8, the answer had to be the first answer choice. Moving on to number 7. It's asking which table would represent this linear function. So first of all, we just look at these coordinates. All right, so I can see that the coordinates we have are going to be, let's see, -1, 3. That's one of them. I can see 0, 0, and I can see 1, -3. So those are 3 coordinates I can see looking at this. So let's have a look at our answer choices and see if we can match any of these up. So let's see, 0, 0, I'm not seeing, oh hang on, it doesn't ask us to match it up, I'm sorry. I misread this problem. This is going to seem silly, but I'm out of time to record this, so here we go. This one isn't asking for which function matches this, it's asking which function has less of a less steep rate of change. So for this one, the rate of change, or the slope, we're going down by 3, we're going over by 1. Meaning for every 1 I go over, we're going down by 3. So the slope here is -3. We're going down by 3 over time. And we want something that is less steep than that. Less steep means it's closer to 0. Because if the slope is 0, it just is a totally flat line. So we're looking for what is something that is less steep than -3, a rate of change that is closer to 0 than -3. So if I look here, we go from 0 to 1. That's going to be the easiest part to look for when x is going from 0 to 1. And we're just going to look how much did it change. So for this one, we went from positive 3 to negative 1, meaning we went from positive 3 and we dropped to negative 1. That is a change of minus 4. So that's more than negative 3. This one won't work. We look at this one. We went from positive 2 to negative 3. So positive 2 all the way down to negative 3. That means we dropped by 5, so minus 5. Again, that's more steep than negative 3. We want a number closer to 0. For this one, negative 4 to negative 12. Well, that one, it dropped by, it looks like 8 to me, so minus 8. We look at this fourth option. We went from negative 1 to negative 2. We only dropped by 1 at a time. Negative 1. So this one is going to be the answer I would have wanted. And if you really wanted to, if you were having trouble with this, you could have simply graphed these on the function above or on the graph above, and you could have seen that it was less steep. So for this one, negative 2, 1, negative 1, 0. Let's go ahead and plot those and see what it would look like. So negative 1, 0 would be here. And then 0, negative 1, 0, negative 2, 0, and then it would have looked something like this. That's not as steep. It's a more shallow line than this one, which is going down pretty fast. So that is how we do questions like this. Let me go ahead and clear that out of the way. For number 10, it's asking us to compare these two functions. So for this, it's asking which function has a greater speed and what is the greater speed. So for function A, we have to dip back into 6th grade a little bit. This is talking about rate of change or slope or just a unit rate. So we want to figure out how many meters per second each of these two functions is going. For function A, 10 seconds, they went 140 minutes, or 140 meters. So we do 140 divided by 10 seconds. So function A, they're traveling at 14 meters per second. And then function B, it says D equals 13s. Well, you can guess what the D and the S stand for. D in this case stands for distance, and S stands for seconds, meaning we're going 13 meters a second. That's what this right here is showing us. We're going 13 times S, which is the number of seconds. Meaning if I went 10 seconds, 10 times 13 would be 130 meters. So, which one is going faster? Well, it'd be function A. Function A, they're traveling at 14 meters per second. Function B is traveling at 13 meters per second. So that's going to be our answer for number 10. For number 11, yes, I know that this one was really, really fuzzy. So we'll just call it a pretend you need glasses simulator. So the two tables show a relationship between the x and y values. What do they have in common? So for this one, we have -1, -1, 0, 1, and 1, 3. Down here, we have 0, 1, 4, -3, and 5, -4. Well, hold on. 0, 1. They both have when x equals 0, that y is 1. Now the question would be, what in the world does that mean? When x equals 0, y equals 1. What they're talking about is that if I have a graph and I were to plot something at x equals 0, meaning when I am on the x-axis, y is going to equal 1. All right? When x is 0, y is 1. Right here, 0, 1. That's what it's talking about. And which intercept is this? Is this the x-intercept or the y-intercept? This is going to be that they have the same x-intercept. All right? When x equals 0, that means I'm on the y-axis. I'm right smack dab in the middle of the graph. So that's what this one's going to be. 2 common points. Yes, but that's not the answer we really wanted. I might change that by the time you guys see it, might not. Because you know what, I'll change it to say which best describes what they have in common. That's what it'll probably say by the time you guys take this. For number 12, compare the two functions shown in the box. All right, well that's weird. It should say 4 functions, but oh well. So we have function 1, function 2, function 3, function 4, and it's asking which of them has a negative slope. So a negative slope, that just means that over time, the graph is moving downward. It means as the x-axis, x number is increasing, the y is decreasing. And honestly, you can kind of skip looking at function 1 and 2. You can just ignore the tables because look at function 4. That graph is very clearly moving downward over time. So we know that one of the answers has to be function 4. Well, there's only one option that has function 4 in it. So we don't even really have to look at function 1. You can see that those numbers are going down over time. But that's the only answer choice that includes 4, which is very obviously negative. So we've got function 4. For number 13, which function has the greatest value when x equals 2? So let's go ahead and just look at our options. For this one, when x equals 2, y is going to equal 6. 2 plus 4, that equals 6. For this one, when I replace that with a 2, we have negative 4 times 2, well that's negative 8. Negative 8 plus 2 is negative 6. Well, obviously negative 6 is much less than positive 6, so it can't be that one. For this one, it doesn't tell us what 2 would have been, but it does tell us that 0, it was negative 1, and 1, it was negative 5, which means 2, if x were to equal 2, it would probably be somewhere right between negative 1 and negative 5, probably about negative 3, which again, negative 3 is less than negative 6, or positive 6, so that can't be it. And then last but not least, for this one, we have, oh wait, that would have been right here actually. 2 would have been between 1 and 3, which means it would have been negative 8 or something like that. Still less, so it's still not C. The last answer choice, if x were to equal 2, y would equal somewhere between 6 and 10, so possibly 8. So this one, this is going to be the largest value for x equals 2. That's what we wanted for this one. Moving on to number 14. This one is asking what is the distance between the y-intercepts of a function p and function q. Function q is here in the graph. Function p is this equation. Well, lucky for us, we've practiced a lot of graphing equations. So we know that this is the y-intercept, positive 4. So 1, 2, 3, and 4. There's the y-intercept. And then the slope is going to be 1 over 2. So we go 1 up and 2 over. 1 up, 2 over. 1 up, 2 over. So that's right here, 1 up and 2 over. And we just kind of repeat that over and over again. And eventually we'll get a straight line. Something like that. There we go. So the question is, what is the distance between the y-intercepts of these functions? Well, the y-intercept for this one is 4. Y-intercept for this one is 2. What's the difference between 2 and 4? 2. 2 minus 4 is 2. All right. I guess I didn't have to plot the entire graph for that one. Moving on to number 15, which equation is non-linear? Remember, non-linear means that there is no variable with an exponent. So it's going to be that one. All right. For number 16, which equation is linear? So again, we want to make sure we avoid anything where x has an exponent, so it's not b and it's not c. We also want to avoid having x in the denominator. It cannot be in the denominator it has to be in the numerator to be okay. So it's going to be this one. For number 17, yes, again, it's blurry. I'm sorry. George recorded the number of words he can type per minute for 4 weeks. Looking at the data within the tables, which table is non-linear? Remember, linear means that it is increasing or decreasing at a constant rate, meaning it's always adding the same amount each time. So 1, 2, 3, 4, 5, good, that's nice and linear. 48, 50, 52, 56, 54, 56, that's counting by 2s. So week 1, perfectly linear. It's going up by increments of 2. Week 2, 51, 54, 57, 60, and 63. It doesn't look like it at first, but it is counting by 3s. So week 2, it's a little weird, but it is linear. Week 3, we have 50, 53, 57, so already something is wrong. 50 plus 3 would have been 53, but if I keep adding 3, I should have gotten 56, and then I should have got 59. But here I got 57. So for some reason I was adding 3, now I'm adding 4. So week 3 would not form a straight line if I were to graph it. And just to double check, week 4, it is counting by increments of 1. It's only going 1 at a time. For number 18, the table shows points from a linear equation. Which linear equation has a graph that includes all of the points in this table? So we're looking for which of these down here matches all of this. Kind of the same thing I did with an earlier problem. I'm just going to pick the easy one. All right, when x equals 1, y should equal 2. So if I replace this with a 1, 1 plus 2 should equal 2. Well, this one obviously didn't work, so that's out. For this one, I replace this with a 1. So we have 1 times negative 3, well, that equals negative 3. Negative 3 plus 5, that does equal 2, so this one works. For this one, we replace that with a 1. 1 minus 6 is very clearly not 2, so that's wrong. And for this one, replace that with a 1. So 3 times 1 is 3, and then 3 minus 5, no, that would equal negative 2. So we have our answer. Again, you don't have to try all of these to find the answer. My advice, pick the one that seems the easiest one to plug in. It's usually going to be something like 1 and something else. Moving right along, for this one, for a math test, you must choose a graph of a nonlinear function. Which graph do you choose? Nonlinear means it is not a perfectly straight line. And that's going to be this one. This one, you can see it has a slight curve to it over time. So it's going to be B. The rest of them, it's almost an optical illusion, but they are all straight. Again, sorry for how blurry some of them came out. And last but not least, number 20, study the 2 functions in the table. Okay, so 1, 2, 3, 4 for function 1, 5, 7, 9, 11 for function 1. So seems linear. They're counting by 1s on the side and 2s on the y side, so that's linear. Function 2, we have 1, 2, 3, 4, so that's linear. And then on the y side, it says negative 7, positive 7, negative 7, positive 7. It's zigzagging back and forth. So function 2, that's not moving in a straight line. So only function 1 is going to be linear in this case. And that's going to be it. Let me double check, make sure there were no typos in that. Oh, there is one. Which one do I have grading incorrectly? I selected the same x-intercept. I'm such a fool. For number 11, I even told you it's the same y-intercept, and I selected the x-intercept. I'm so sorry if you watched this and I said that, but I'm not going to go back and re-record another half hour. So that's going to do it for this. I hope that this study guide helps. Remember, if you did not get a 100, go through, check the rest of this video, see what else you could have improved, and make sure that when you are studying, don't ask yourself if you remember what the answer is. Ask yourself if you remember how to get the answer or why the answer is what it is. In any case, good luck, and I'll see you later.